Here we're looking at example 1 from section 2, chapter 1, and this whole chapter, or excuse me, this whole section here deals with limits. And so the limit is the value that the function approaches or takes on as we get very close to this number 4 down here, but not actually equal to it. So here's what the limit is not. The limit, as x approaches 4, of 1 over 4x minus 2 is not the same. So we're assuming here that the function f of x is equal to 1 over 4x minus 2. The limit is not necessarily the same as the function evaluated at 4, meaning if we just plug in 4. Now it is true for continuous functions, but the definition of continuity depends on limits, so we can't use this. Okay, we'll go through some rules for when we can use this and when we can't, but right off the bat we shouldn't use that. Even though it does turn out to be true, we can just plug in 4 here and get our value. So how can we do this numerically? When they say numerical, what they're asking for is to make a table. Okay, so we're going to go ahead and make a table of values. And our table of values are going to be x values that are close to 4. And we should do it from both sides. So the picture, the graph of it, let me draw that guy out as well here. This guy at 1, 2, 3, 4. Okay, here's a height value of 1. This guy maybe looks something like this. And the question is, as we pick x values that come in from both sides, what is the height value that we appear to be approaching? So this is what we want to know, is roughly what's the height as we come in from both sides. Now we don't actually want to know the height at that actual point because, for example, there could be a hole here and we could redefine the function to be up here. And so the height of the function at that point might be here, but the limit is what happens as we come in towards this point. So what do the numbers approach, not what are they actually at that value. So what we do is we make a table of values for our numerical computation. And we say something like this. We'll say, okay, let's take a look at x and f of x. And let's start picking x values that are close to 4 from the left-hand side, from over here. So here's 4. And let's pick some numbers that get close to 4. Like let's say we do 3.8, 3.9. I'm just picking numbers here that are getting closer and closer to 4. Okay, there's a whole bunch of numbers that are getting increasingly closer to 4. So now let's go ahead and figure out what the function values are. So to figure out these function values, what we do is we take this 3.8 and we plug it in over here. So this guy right here is 1 over 4 times 3.8 minus 2. So we need to make sure that we're using parentheses on our calculator. And I'm getting 0.075 repeating. Okay, that's that guy. So what that says is if we take the height here at 3.8, its height value comes out to be 0.075. Now we're going to move a little bit closer to 3.9. Okay, so when I plug in 3.9 into that, okay, so I do 1 over 4 times 3.9 minus 2. and I get out 0.074 approximately. That's approximately because it's 0.0735. So what happened? Well, we got a little bit closer. We went up and we came over and we found out that this height was 0.074. Now we're going to keep the number that we're approaching here is 4, right? So we're going to keep getting closer and closer. So let me go ahead and give you these values here. I'm going to compute them out. So if I put in 3.95, I get 0.072 approximately. If I put in 3.99, I get in 0.0716. I'm going to go out just a little bit further in my decimals here. So if I put in 3.99, excuse me, 3.999, I get 0.0714. And if I put in 3.9999 with 4 nines, I don't know if I said that right or not, but 4 nines, I again get 0.07143. This was 0.07145 if you round it. Okay? So what we're doing is we're approaching these numbers as we go. These numbers look like they're all approaching a good guess. Okay, so we're trying to guess the value. A good guess from the left side, coming in from the left side, would be 0.0714. That's a pretty good. I mean, we're already out to what? So tenths, hundredths, thousands, 10,000 spots. I mean, it depends on our accuracy how far we want to go, but this guy's pretty good. Now we can't just do it from one side. We also have to come in from the other side. So we start picking some values here. Okay, so I want to come in, let's say from 4.2, 4.1. Notice I'm coming in. Here's 4.2, here's 4.1. Okay, we're coming closer and closer to 4. Let's do 4.01, 4.001, and 4.0001. Okay, so we take all those and we're going to plug them into this function up here. And if we do just 4.2, I get out 0.07 or 0.0676 approximately. If I plug in 4.1, 0.0694, 0.01, this guy right here, 4.01, gives me 0.0712. Put an extra 0 in there, and we get 0.0714. And if I put one more in, I'm going to get the same thing. Okay, so our guess is that from the right side, we also, our guess is 0.0714. Now here's the thing about the limits. As you come in from the left, we approach 0.0714 for the height values. As we come in from this side, and let me actually draw out a better picture here for you so you can see these guys a little bit more closely. Believe me, it's worth taking the time to sit and. So here's 4. Let's say here is 3.8, 3.9, so on and so forth, 3.95. What we found is that the height values got closer and closer. These guys got closer and closer to 0.0. That doesn't write well on the side there. 0.0714. These values trended towards 0.0714. Then we came in from the other side and we said, okay, here's 4.2, here's 4.1, here's 4.01. And then we started taking these guys and we started looking at their heights. And we started looking at what are they trending towards. And we also got that they were trending towards 0.0714. And the idea is that if they both are trending to the same thing, then the limit exists. And the limit as x approaches 4 of 1 over 4x minus 2 is equal to 2.0714. These guys have got to both agree. If one is approaching a number and the other one's approaching a different number, all bets are off. So for example, if your function, let's erase all this. If I was doing the table of values and like this side came out to be 0.0714 and this side came out to be 2.36, okay, then if these guys don't agree, then there is no limit. We say that the limit, instead of writing this down, we would say that it does not exist. Okay, but since as we come in from both sides, since both limit values, the limit from the left, and actually that's what we call this guy right here, when we do this, let me give you a little notation because this is important. This guy right here is the limit as x approaches 4 from the left. What we mean is that on the x-axis, if here's 4, we're coming in from the left side, from the left. And we put a little negative up top. So the limit as we come in to 4 from the left side, this is called a one-sided limit, of 1 over 4x minus 2, that guy is equal to this. This guy is the limit as we come in from the right. I won't have a whole lot of room over here to write it, so I'm just going to put it down here. Limit as x approaches 4 from the right side, that means coming in from this side, of 1 over 4x minus 2, that's equal to this guy. Let me erase these guys right here because we're not using those anymore. I don't want you to get confused. So the limit from the right is the same as the limit from the left. And when those are the same, then we just say the overall limit exists as 0.0714. Now, had you just plugged in 4 into here, you'd have 1 over 4x minus 2 is equal to 1 over 16 minus 2, which is 1 over 14. And if you take 1 divided by 14, guess what you get? You get these values. Now you might say, well, why do we go through all of this work when we can just plug it in? And that's a good question. Well, we can just plug it in if the function's continuous. So this function is continuous, not everywhere. It's not continuous at a half, but it's continuous around the point 4. So it is continuous around this guy. So we can just plug it in. However, we have to be very careful with that because the limits, the continuity that we're using here depends on the limit. So it's like we're using what we're trying to actually show to show that it's logically doesn't make any sense. So what you need to do is, for these problems, I'm going to ask you, go through and do a numerical computation. You show me that both sides are equal to the same value, or maybe they're not. If they're not equal to it, then you say the limit doesn't exist. If they are equal to each other, then you say the limit exists and it's equal to these values. And you can always check for continuous functions by taking the value and plugging it in and making sure that you get that same value out.